Okay, so today we're going to look at some polynomials and just different forms that they could be written in, and in those forms how to solve or to find zeros. Now, first of all, I gave you a polynomial, and probably technically to be a polynomial I should have had a y equals here, but I gave this to you in factored form. We factored before, see how this is factored? Now it's going to be hard for us to factor some of these on our own. The ones I'm giving you today are doable. Later we're going to have some that are a little bit harder. What I want us to do is write this in standard form, which means I'll have a something x to the third plus something x squared, etc. So what I'm going to go through and do is I'm just going to FOIL those two together. I'm going to leave that x plus 1. I can FOIL these together. So first, outside, inside, last, and combine my like terms. So x squared plus 5x plus 6. And then I'm just going to go through and distribute. So I'll distribute out my x. Then I'll distribute out my, what color do I want to use? Then I'll distribute out my 1, and then I'll combine like terms. So let's start with the x. So x times x squared is x to the third plus 5x squared plus 6x. Okay, then I'm going to distribute out the 1. Now I like to stack them, so 1 times x squared is x squared. I'm going to put it right there where I'm easy to combine like terms in my next step. Plus 5x plus 6. And so I lined up my like terms so it'll be easy to combine. So x to the third plus 6x squared plus 11x plus 6. And like I said, I probably should have had a y equals, but I didn't. Okay, now I want us to go the opposite direction on this one. I'm giving this to you in standard form. I want us to write it in factored form. So I'm going to factor this thing. Now, I can't give you anything that we can't factor today, so you should be able to factor it. So I'm going to start by pulling out a 2 and pulling out an x. So I'll have x squared plus 5x, when I pull out the 2x from there, plus 6. Now see how what I have left here is something that I can factor, so I'm going to do that. So plus 2 and plus 3. So there's that written in factored form. Here's one more of these. So I'm going to kind of start the same way. Pull out anything I can pull out. I can pull out a 3x and write out what I have left. And then I'll factor what's here in my parentheses. So x minus 4 and x plus 3. Okay, now one main thing that we're going to do in this section is we're going to go through and solve. I want to remind you that another way that you can phrase solving is to find the zeros. That's how I phrased it here, which is the same thing as finding x-intercepts, which is the same thing as roots. So when we're solving this, finding the zeros, that means we're looking for where it crosses the x-axis. Now basically, if we're talking about where it crosses the x-axis, that's where your y value is 0. So even if it's written with a y, if you're finding the zeros, that's when your y equals 0. Now we're going to do this one two ways. First of all, I want us to go through and I want us to solve this or find the zeros by factoring. Then we'll go back and I want us to do it by graphing. Okay, so I'm going to factor this thing. So plus 2 minus 1, and then set those equal to 0 and solve. So negative 2 and 1. Okay, so here are my answers. I'm going to graph this thing. So I'm just going to go back, graph the original. So I'm going to clear out what I have in there. And I'm going to put in x squared plus x minus 2. And graph this thing. Now, here's what I want you to see. Remember, finding the zeros is the same as finding the x-intercepts. See how it crosses the x-axis right here at -2 and at 1? That's not a coincidence that those are the same numbers as I got for my answers here when I factored. It's finding the same thing. When you're solving, you're finding where it crosses the x-axis. Okay? Okay, so let's find a couple more. So because this one's a little bit big, I went ahead and gave it to you in factored form. If it was multiplied out, it's not something you'd be able to factor. So remember, if we're looking for zeros, that means that my y is 0. And all I need to do is set each of these equal to 0 and solve. So -2, -1. Now I said this wrong. Let me go back to this one right here. When I set that equal to 0 and solve, I'll get positive 2 because I'll set it equal to 0 and move the 2 over. I'll get positive 2. So that was my bad. And -3. Okay, now quickly, I'm going to go through and graph that. I just want you to see what's going to happen. I think that you can probably already guess that when I factor this, it's going to cross the x-axis at those 3 places. But I want you to see it in case you don't, believe me or whatever. Okay, so you'll see this time it's not a quadratic, so it's not a parabola. If I were to multiply all that stuff out, I'd get an x to the 3rd, but here it crosses at -1, 2, 3, -3, -1, and 2. Same values that we got right here. That happens every time. Remember, if you do the factoring bit, you'll get the same zeros as if you look at your graph. Now make sure you can do it either way, because I probably will give you a calculator part and a no calculator part, so you need to be able to do it both ways. Okay, now if I were to go through and write this out, I'm going to just write out what I have here. You don't have to do this every time, but I just want you to see it on this first one. Okay, so x plus 6 is to the 3rd power, so there's 3 of them. So when I set these equal to 0 and solve, here are my answers. 3, -6, -6, -6. Now, to write that -6 repeats 3 times, you don't have to write it out 3 times. You can just say that the -6 has multiplicity, I put the word up here, multiplicity of 3. Multiplicity means how many times does that answer repeat. Now what about the 3? Don't think about what the multiplicity would be on the 3. It only repeats 1 time, so it has a multiplicity of 1. Okay, now let's put some of this stuff together. Okay, so looking at this, let's go through and let's find the zeros. So this time I used f of x, that's the same as y. I want that to equal 0. And I'm going to try to factor this thing. So I can pull out an x squared. I'll have x squared minus 8x plus 16. And then I'm going to factor what's there in the parentheses. So let's see, -4 minus 4. So double check that if you want. Okay, so here's what I have if I write it out. X squared is x times x minus 4, x minus 4. Now, this is an x to the 4th problem originally. I should have 4 answers. So I'm going to set each of these equal to 0, and well, I don't really have anything to solve there. Here, I'm going to set it equal to 0 and solve. Okay, so here are my answers. 0, and it repeats twice, so multiplicity of 2. And 4, also multiplicity of 2. So it's all about factoring. Now, I want us to go back to the problem we did a minute ago, just because I want you to see this. Well, actually, we'll do that tomorrow. Okay, so the last thing I want us to do is practice a little bit on using our calculators. On here, what I want us to go through and do is find any maximums or minimums. Now here I use the word relative because relative just means it doesn't have to be a maximum or a minimum for the whole thing, but just for that one little area, as well as our zeros. So those are the things that I want us to go through and find. We're going to find them on our calculator. So I'm going to come back over here, go to my y equals, and I'm going to put that thing in. So 2x to the 3rd, I'm going to use my little caret top here, minus 23x squared. Now if you have a calculator like mine where it puts that up in the exponent, if it were me, if it's squared, use this one because it'll just put the 2 up and then put it back down, whereas if you use the caret top, you have to tell it when to go back down, which I think is kind of a pain. Plus 78x minus 72. Okay, and I'm going to graph this thing. Now, this thing is an x to the 3rd, so I should have 3 zeros, 1, 2, 3. Now, this one is at 1, 2, 3 at 4, and this one's at 6. If I'm not sure, I can double check that on the table. Go ahead and go down where I can see 6. So here it's 6 at 0, here at 4 at 0. So 4 and 6 are 2 of my zeros. The other one is going to be a little bit harder to find because it's at a fractional value there. So I'm going to go to my calc menu, second calc, and I'm going to ask it to find a 0. Okay, now let me find my cursor before I do anything. Okay, so here's my cursor. Now it's going to ask me for a left bound and then for a right bound. So if I'm looking for this, my left bound, my values are down where I'm at right now. So I'm going to go ahead and hit enter. And then they ask for a right bound. The right hand side of what I'm looking for is over here. So I'm going to move my cursor to where I'm on the right hand side. Hit enter. Now your little arrows should be pointing at each other. If they're not, you gave the wrong sides of the thing. So make sure they're pointing at each other or you'll get an error. If you want to guess, you can. I've never really seen anyone guess. If not, hit enter. And it will give you the value of that 0. So you'll see the y value 0. Now occasionally, and we've had this before, occasionally the calculator will have a little rounding error, and this will be something in scientific notation. If it's in scientific notation, that means it's small enough that it's just a rounding error. And the x value is your actual 0, which is 1.5. I'm going to write it as 1 1/2. Okay, now that's great. Now let's go through and let's find our relative maximums and our relative minimums. Okay, so I'm going to come back over here. Now, looking at this, here's a minimum. My maximum, it might be off the screen just a little bit, but I should still be able to find it with the left bound, right bound. So I'm going to find the maximum first. It doesn't really matter what order you find these in. I'm going to go back to that same menu, second calc, and I'm going to find a maximum. Now everything on here really works the same way. It's just telling the calculator what to look for. So I'm looking for a maximum, then it's going to ask me for the left bound, right bound. Okay, now my maximum, and maybe I should have changed the screen because it's up here where I can't see it, but I'm on the left-hand side of it right now. So I'm going to hit enter, and then I'm going to go around to where I'm on the right-hand side of it, right bound, and I'm just going to go far enough that I can tell where I'm at. Okay, so there I am. Okay, those two little arrows should be pointing at each other. Sometimes they're hard to see if they're on top of the graph. Guess if you want, if not, hit enter. Okay, so my maximum, and we're just going to round to 2 decimal places, is 2.53, 10.51. So 2.53, 10.51. Okay, and then let's find the minimum, which is right here. I'm going to do the exact same thing. Second calc, minimum, which is number 3, and then I'm going to do the left bound, right bound. Okay, now let me go to where I can find my cursor. Okay, there's my cursor. Now here's what I'm looking to find, my minimum. So left bound, which is what they're asking me first, is over here. So where I'm at's fine. Anywhere on the left-hand side's great. Okay, scroll over to where I'm on the right-hand side. Arrows should be pointing at each other. Guess if you want, if not, hit enter. And it gave me my value here. So 5.14, I'll round that up, and negative 7.14. Okay, now this concept right here, you want to get good at because you're going to see this actually quite a lot. Sometimes people have a little bit of a hard time getting their mind around the left bound, right bound. Once you get it though, there's lots of different things that you can find using that menu and the left bound, right bound. You can find zeros, maximums, minimums. I think there are a few other things. So that's something that you want to get down because you'll use it a lot. And next year in either Algebra 3 or Pre-Cal, you'll also use it a lot. All right, so this is 6.2.